All right, metric prefixes part 2. So hopefully you've had a chance to look at part 1. And I can promise, more Greek mythological monsters in this one. So I'm sure you'll be excited about that. We still want to talk about metric prefixes though, because we want to, we know what they are, but we want to know how to handle them, right? How to use them in equations and do conversions and stuff like that. All right. So let's see what else we can do here. We want to convert metric prefixes to basic units now. So milliliters to liters. So M is milli. So milliliters is M, and it's 10 to minus 3 according to the chart, right? So this stuff you just have to know. Centimeters, millimeters, or centi, milli, kilo, mega. You just have to know. It doesn't, milli is like a million, I guess, but I don't know. It's something you probably just have to memorize. Or you can say 1 milliliter is equal to 1 times 10 to the minus 3 liters, right? So, just another way of looking at the same kind of thing. So I have 5. This is pretty easy. This is really straightforward. 56.7 milliliters. Well, let's replace milli by 10 to the minus 3 because that's what it means, right? And liters, right? And then, well, we can put it in scientific notation, moving the decimal place to the left. So the power of 10 is going to go up, left, up. So put it in scientific notation. So this is really straightforward, right? So all you do is replace m by the exponent that it represents. And this, as you may already know, is a Cyclops, another Greek mythological monster that's featured in Percy Jackson and the Olympians. Okay, so convert metric prefixes to basic units again. Let's try another one here. 56.7. I'm getting lazy here using the same number again. But now it's centiseconds, right? You can have a centisecond, right? Centi C is equal to 10 to the minus 2. I think we saw that on the previous part. And so one centisecond is equal to 1 times 10 to the minus 2 seconds. That's another equality we could write, putting into the units there. So we already have a power of 10 here. So 56.7 times 10 to the second. And then centi is 10 to the minus second, right? Or we can place centi by 10 to the minus second, and now we have seconds. So now we have to do some, addition of exponents, right? So if we're multiplying powers 10 to something, we can add the exponents to plus minus 2. We're going to add the exponents together because we're multiplying the powers of 10, and we're going to it's going to drop out, right? 56.7 times 10 to the 0, which is 1, which we usually just drop. 56.7 seconds are units, right? And so, if you already have a exponent there, do not fear. We can deal with that. Multiplication. You end up adding the exponents together. And this is Cerberus. Cerberus, the 3-headed dog that guards the gates of Hades, I believe. What else might we want to do? Convert between metric prefixes. Okay, well, this is going to be a little more involved, right? Because now we have two metric prefixes to deal with. In this case, we have kilo. K is kilo and equal to 10 to the third. M, big M, capital M, mega, 10 to the sixth, right? This stuff is from the table, kilo and mega. So we can do it this standard notation way. 6,700 kilograms is 6,700 times 10 to the third grams, right? We can replace kilo by 10 to the 3, and we can add 3 places onto the number to get to the standard notation number without the power of 10. And now we're in grams, right? We've converted to grams and converted to the standard number in grams. And now we want to we want to replace 10 to the 6th by mega. So we move the decimal point over 6 places to the left. Left goes up, so it's going to be 6.7 times 10 to the 6th grams, and we know that we can replace 10 to the 6th with megagrams. Megagrams. 6.7 megagrams. Right, so convert it to grams, standard notation, and then convert it back to the metric prefix. Right. One way to do it. We can also do this with dimensional analysis as well. We don't have to move the decimal place back and forth, but we do have to do some other arithmetic type things. So we can take our starting kilogram as one factor, right? That's one factor 1, and then I want kilogram to cancel out, so I use the conversion 10 to the third gram over kilogram is 1, right? Place k by 10 to the third, and then I want the kilogram to cancel out. I cancel out the kilogram. I want the gram to cancel out, so I put megagram is over 10 to the minus 10 to the 6th gram is another factor, another equality. Okay, and now, according to the wisdom of math here, we can cancel out those units, and we end up with megagram, which we wanted to, right? Converted kilogram to megagram with adding 2 conversion factors in there. And now we have to sort out the numbers here, right? Times 10 to the third divided by 10 to the 6th. So that means that you subtract the exponents, right? 10 to the third divided by 10 to the 6th is 10 to the 3 minus 6. And now we've made our conversion to megagrams here. And so we're not quite done yet. 6700 times 10 to the minus 3 megagram. And then move the decimal point over to get it into scientific notation. Right, we start over here, move the decimal place over 1, 2, 3 spots to increase the exponent here from minus 3 to 0. Right, and then we end up at 6.7 megagram. All right, so 2 ways of doing this conversion, and actually, the dimensional analysis way is not so bad, and actually we use a dimensional analysis for a lot of other problem-solving type things, so it's something that is probably good to practice. But it's good to have options, so you can check your answer, right? That's always a good thing. 2 different ways of doing the problem. You can do both ways and use that as a way to check your answer. One more. Oh, 2 more we've got to deal with here. Calculations with metric prefixes. Addition. So addition, the thing is you have to you have to make the units agree, right? Addition, you have to make units agree. And so centimeters and meters, right? So we have to convert centimeters to meters or convert meters to centimeters. It's easy to convert centimeters to meters, right? Because so that's usually the way I would go with this one, you know, because all I have to do to convert centimeters to meters is replace centi by 10 to the minus 2. How easy is that, right? And now it's in meters, and 0.54 meters, right? Same. Okay, so you know, this is the same. If I move it over, without the exponent on there is 0.103, so I can do the addition here, right? 0.103 plus 0.54 is equal to 0.1. What was it equal to? Okay, 0.643. Sorry. Right, 0.643, and it would have been. You can do the, you know, stack them up. Addition seems like it's always better to do it that way, right? To stack them up and then see what happens when I try to do things in my head like that, right? That's probably a better way to do it. 0.643, and now our units are in meters. And okay, well, it's not in scientific notation. We could move it 6.43, get rid of that 0, right? Moving the decimal point to the right, so it's 10 to the minus 1. Scientific notation gets rid of that 0. But, well, what about sig figs? Oh, yeah, we got to remember sig figs. Well, that's a good thing I did stack the plot like that, right? Because sig figs tells me that the last one here, the thousandths place, is not going to be significant because only the 0.54 is only significant to the hundredths place. So I have to drop the last one, right? I have to drop that. I just love slashing things with my red marker. 6.4 times 10 to the minus 1 meters, right? Significant figures. We got to remember significant figures when we do calculations. Okay, so what else we got here? Calculations with metric prefixes. Now we're doing multiplication. So as we remember, centimeters is 10 to the minus 2, kilometers is 10 to the third. So I can make those conversions pretty easily. 10 to the third times 10 to the minus second meters times 0.54 times 10 to the third meters, right? Centi is 10 to the minus second, kilo 10 to the third. This stuff I have to know, these prefixes. And it's just a big equation now, right? So I want to group the like terms. So 10.3 times 0.54, and then the exponents, I can add the exponents, 10 to the minus second plus 3. And what you have to remember, you also have to multiply the units, because this is multiplication, so it's like finding the area of something, right? Like finding the area of a rectangle that has sides, one side of 10.3 centimeters, the other side of 0.54 kilometers. It's kind of a large rectangle. but you're going to have to multiply the units together, right? So it becomes meters squared. So you also have to make the units agree. Yeah, so make units agree. You should put that on here as well because it works. Have to do that for multiplication, division as well. And we haven't quite done with our numbers here yet. If I do the multiplication, I end up with 5.562 times 10 to the first meters squared. Okay. So writing scientific notation, that's nice. Well, what about the sig figs? Sig figs. Sig figs, I have three sig figs here. Here I only have 2 sig figs. So I only can have 2 sig figs in my answer. I have to drop the 6 and the 2, and in dropping the 6 and the 2, I have to increase the 5 to 6, right? To the rounding principles, 10 to the second meters squared. All right. So I got to remember sig figs when I do calculations, and so. But I can do that and wait till the end to do that with multiplication, a simple multiplication. And oh yes, the Greek monster there is the Ophiuchorus, which also figures in Percy Jackson and the Olympians. If you didn't catch I don't think I said what the other one was. The other one here is Typhon. Typhon, the storm maker kind of thing, right? So that's the Greek character there. Okay, now I'm done.